this webinar for Io-Tahoe. This is combining the power of data catalogs with artificial intelligence. Neil Raden is our guest today. He is the CEO and principal analyst at Hired Brains Research. If you want to join this conversation, we can send a couple of comments over to the side in the chat box. We'll do our best to keep track of what's going on there. You can also tweet it using Io-Tahoe's Twitter handle, as well as the hashtags AI and data catalogs. You'll see the chat panel there in the lower corner of your screen. We are recording this conversation right now, and it will be available at this website that you see. It will also be available for download at Io-Tahoe webinars. The agenda today is pretty simple. We're going to take a look at data preparation and the 80-20 conundrum. It's a conundrum that's not unique to data preparation or analytics, but it has a very special meaning in this case. And the question that Neil is going to address over the next 50, 60 minutes or so is, can machine learning beat this conundrum? Taking it one step further, we'll talk about machine learning, relationships, and data flow, and also then get into the question of data catalogs and the question of semantically rich. What does that mean? How does that pertain? So, Neil, I'm going to turn it over to you at this point. I'll do my darndest to keep up with you on the slides, but have at it, sir.
Okay. Thanks a lot. I appreciate it. You know, I guess you could say the sort of crushing problem of managing data today in what's an increasingly complicated and hybrid and distributed world, it's really too great for a highly skilled analyst or a data scientist to handle alone. The solution is really a platform that provides, I guess you'd say, sort of coherent, connected services like data relationship discovery, which we're going to talk about in a second. It's an interesting topic. But also data flow, because data isn't static in an organization. And in the old days of data warehousing, ETL existed in two realms. One was, of course, the initial load into a data warehouse, which was massive, and then the periodic update. But data is more continuous and more vibrant now because of the various sources, especially the ones beyond the firewall. You have to have impact analysis, understand what's happening to it, redundant data analysis. You need to understand if there's sensitive data in the data that you don't realize, and that's a very important thing, and we're going to talk about that in a minute. But really, most importantly of all, for all of this effort to be useful, you have to have that semantically rich data catalog. Now, data catalogs are interesting, and they've been around for a little while, but in a lot of cases, they haven't been successful because they've involved far too much manual effort and writing of code, and it just sort of shifted the effort from one place to another. But we think we have a solution to that, and that's one of the things that we want to talk about. Okay, do I have control of this, Mark, or do you?
Actually, I do.
I'm sorry?
So we'll go to the next slide, and you can see there where it says that data scientists spend up to 80% of their time getting ready for the data, to analyze the data. That's a real problem.
And you know, the real problem today is not the volume of data, which everybody's been complaining about for years now. It's making sense of it and doing that at scale and continuously. So that's what we really want to talk about today. So what we've sort of figured out, speaking to our clients, is that embedded AI and machine learning technology, not manual effort, is essential for doing this work, that it's impossible to do without it. The other thing is, it's just not machine learning or AI techniques to find data or to clean data or to profile data. What's really essential is understanding the relationships swap between data in many different sources, and we're going to talk about that for a minute. And data discovery, like I said a minute ago, is dynamic. It's not a one-time mapping to a stable schema like a data warehouse, and that includes or implies a lot of complexity. Metadata, boy, we've been talking about metadata for 20 years. I used to say that metadata was just dead data in a drawer, carefully organized. Metadata has to be active, and it has to be useful, and ultimately it has to exist not for IT, but for people who are doing work with data so that they can understand the data and they can use the data and ultimately improve it and share it. AI-driven software has got to go beyond the technical metadata. I know you've probably seen this before, but a lot of these tools really don't go much farther than looking at the column names. That's not adequate. The tools have got to dig into the data itself. I had this joke with a client that said, oh, well, you know, I could tell by the column name that these were names of doctors. And I said, well, how do you know that it wasn't Doctor Who? And you wouldn't know that unless you looked at the information, right? The other thing that's important is you can't rely on machine learning and AI to give you precise and completely accurate information. It still requires the review and the input by experts and data stewards and that sort of thing. But that isn't enough either. What is enough is for the algorithms to absorb that manual input and add it back into its training so that it can continuously relearn and adapt. Okay, Mark, there we go. I didn't even have to ask. Mark, you're a great producer, you know that?
It's frightening, isn't it?
So when I say the great machine learning hope, I mean, we can get into an academic discussion about what's machine learning and what's artificial intelligence. And you know, I don't even think that's productive. The important thing is you have to have the right tools for the right job. But machine learning has, when I say in the past, I don't even know when machine learning became machine learning, because if you look at the top 10 algorithms that are used in machine learning, 8 of them have been used for 20 years or more by statisticians and predictive analysis and so forth. What really distinguishes machine learning from prior statistical analysis or quantitative methods is machine learning is really driven by massive quantities of data. You have to create huge data sets so that it can really figure out what's going on. The other thing is that machine learning was used not just to understand the data, but actually to create experiments for prediction and implementation. And the learning part of machine learning, when we say machine learning, well, what does it really mean when a machine learns something? It's a nice term. It's a little bit misleading. I don't actually think what we call machine learning is learning. In fact, there was something interesting happened just recently. There's a fellow named Judea Pearl. Pearl is at USC, and he is famous for the invention of something called Bayesian belief networks. His concept is that machine learning is nothing more than curve fitting. And until you can understand causality, you really haven't learned anything. Now, I think there's a certain amount of truth to what Pearl has said. And if you're interested in the topic, you should pick up his new book called The Book of Why. But I think there's a great deal of value that can be generated from machine learning that is curve fitting. And we're going to talk about that in a minute. But the real question
Neil,
I have right now, I'm sorry?
Yeah, Neil, let me interrupt you just for 1 second. And you brought up an interesting point that machine learning has been around for a while, but one of the things we're hearing from a lot of business folks is that it's becoming more and more of a gotta have as opposed to a nice to have, because companies are saving far more data than ever before. There's more privacy regulations in place anymore which guard or govern the use of that data. You need to know what's where and how many places you have it and that sort of thing. Am I right?
Right. Well, it's an interesting topic. And like I said about machine learning, whether it's learning or not is interesting. Whether it's artificial intelligence or not is interesting. but as the late great data scientist Mao Zedong said, I don't care if a cat has a tail or not, as long as it catches mice. And that's kind of how I feel about machine learning. The definitions are a little bit squishy, but honestly, for a machine learning algorithm to learn, it has to sift through lots of data, and it has to do that using a variety of statistical methods to find relationships and patterns and connections in the data itself. So, but what machine learning really lacks is this causality thing. And I don't think that data wrangling and generating analytical tools in an organization, a great deal of work can be done without dealing with the causality issue, because frankly, causality is really, really hard. That's all I have to say about it. I think that machine learning is the best hope right now to beat this 80-20 conundrum. And by the way, I don't know if there is an 80-20 conundrum. We've seen this, data scientists and analysts spend 80% of their time wrangling data, and only 20% of doing their useful job. There's no formal study of that. But I think that it is good enough to indicate that the problem with getting the data to do the work is a real problem. So I'm not hooked on 80%, but it's probably significant. Now, how would machine learning beat this 80-20 thing? Well, the first thing is it's got to scale. So if you have software that's going to help you with the data, it's got to be bulletproof. It's got to be able to scale to very, very large quantities, and not just the amount of data, but also the amount of processing, because a lot of this is iterative. Maybe you only have 2 terabytes of data, but you're going to sift through it times. The algorithms themselves have to operate in an unsupervised way. In other words, you do your feature selection, you point the algorithms at the data, and you say, go exude some pearls like an oyster of wisdom. But there's also the supervised way, which is, I'm going to direct you now. I'm going to give you some corrections. You missed a point here. This connection is not valid. Okay, and that kind of continuous relearning and adapting is important. And what I've seen in my research is a lot of work that claims to use machine learning to assist in this process is really not capable of that continuous relearning and adaptation, and that's key. Okay.
It sounds like you're saying that is the absolute gotta have in today's environment, that it has to be dynamic, that it just can't be a one size, one time fits all.
Well, I mean, it certainly is, Mark. I don't know if it's the one thing. There's a lot of things, and in fact, that's where we're going right now. What are the lot of things? Okay. So let's talk about what these components really are. So let me have the next slide. Okay. I guess the number one issue here is relationship discovery, because when you find the relationships between the sources and the data and the instances of the data, then you really have something that can build a semantically rich data catalog that's useful for people who are doing this work. I would say that really modeling this information in relational databases, which is the way it's been done in the past, it kind of serves the purposes of transactional integrity, archival, general referential uses, but it also causes a really high number of many-to-many relationships, and that in turn leads to a succession of very costly join operations when querying the data. They're not simple aggregate solutions that we're looking for, like key value stores or column family stores or document databases, because the graph that underlies relationship modeling can traverse relationships very easily instead of joining large tables. It can really efficiently tease out the inferences that can only be drawn from SQL by essentially asking for them first. I had another thought and I forgot what it was, but let's take a look at that slide again. Finding these relationships by hand is impossible. You just simply cannot do it. Technical metadata, the column names and so forth, that's a good start, but you really have to look at the data to understand what you have. We've already talked about using AI in supervised and unsupervised learning modes, but it breaks down those similarities and it converges quickly. The thing about a relationship map is it's designed to, how can I say this? When you model things in a, say, a graph structure, which is what a relationship map really is, it can actually give you more information than you asked for. You know, it's like filling your car up with a tank of gas and then driving 100 miles and having to drain some gas off because you've made more than you've used. That's the way I would explain it. Okay, and what they really reveal. I guess the insights you can get from it are finding unusual activity, fraud, traffic patterns, ticket purchases. You know, you've heard about all this before. The industry is replete with examples of these being applications that can be done. Crime prevention, detecting, I like the last one, detecting influencers. Let me talk about that in a second. The problem is, in all of those use cases or case studies, no one really explains how they actually found all that. And the answer is auto-discovery. That's the only way you're going to get through that. Analyzing traffic and performance of power grids. I don't know if you're involved in that. Optimization. Optimization, you know, we have you know, descriptive analytics, we have predictive analytics, we have prescriptive analytics. And when you get through all of that, the next question is, well, what about optimization? Now I know all of this. Tell me what the best thing to do is, right? You know, what's the best route? What's the best supply chain? What's the best, you know, yield management process to go through? Okay. Life sciences, the applications for this in life sciences are just exploding. They have so much data, and they really don't know what to do with most of it because they haven't mapped out the relationships yet. Now, this influencers and groups, this is a really, really interesting application, and I've seen a number of them lately. And the one that I saw lately is a company that gathers information about providers, doctors, basically, writing prescriptions. And you can say, well, you know, this guy, you know, wrote 100 prescriptions, and this lady wrote 150 prescriptions. But that doesn't tell you anything about how influential they are in terms of providing information to other practitioners who want to follow their lead. It's a really, really interesting application, and it is based entirely on relationship mapping. Okay.
It almost sounds like what you're saying there, Neil, is that the potential for this, I may be belaboring the point, but the potential for this is only limited by your thinking of what can we do with the data. And many times it may be just what can the data tell us that we haven't even thought about asking.
Yeah. You know what, Steve? I agree with you 80-20 on that. I still think the truth is not necessarily in the data. There has to be the human element of, well, what if? Or I was thinking the other day that maybe there's a different way of looking at this. And that's why you need a platform like this to enable that kind of thinking and that kind of work. Right?
Well, that's always been the case. I mean, the data only gets you so far. It's what human beings do with the data that may be the real key here. And that may be, if you will, the 80-20, not a conundrum, but a potential that the data does 80% of the work, and it's the human beings who put 20% into context, given all the options, given all the potential, and say, let's head in this direction.
But there's this mass hallucination that the truth is in the data, which I don't really accept. And the reason for that is if you think about data, you know, what is data? A lot of it isn't necessarily real. It depends on how the system captured certain data and how it recorded it. And it doesn't mean that it's an adequate representation of reality for you to go make decisions about, you know, air traffic control. So I still believe the human element is very, very important in continuing to build, good outcomes. But again, I'm going to harp on this again. It's the data catalog that's semantically rich, that creates collaboration, understanding, and all of those good things that allow people who use quantitative methods to do a better job. And I think that's important. Data flow is basically discovery of how the data flows through the organization. Now, actually, I think that may be a little narrow. It's not just the organization. It would be how the data flows really through anything in the source systems you're trying to evaluate. Understanding the relationships between columns and data sources and databases and the affinities of the data itself is where data flow is important. Now, I didn't want to put up a diagram of one more set of boxes and arrows of accounts payable and Twitter and Equifax. So I used this example from molecular biology of tRNA transcription, and I'm not going to try to explain it because, to tell you the truth, I only understand it a little bit. But I think what you can see is there's a tremendous amount of interaction and relationship between all the different entities. And that's what we're trying to get at with data flow. And not a static interaction between entities, but the flow itself. Okay? Okay, Mark. Sensitive data. There are so many new regulations about sensitive data. Obviously, everybody knows about GDPR. Well, maybe not everybody, but it's a burning issue. And because GDPR's reach is not just within the EU, it's within any organization or process that touches the EU, and that pretty much means everybody. So GDPR will, begrudgingly become probably the international standard for this. And we all know about HIPAA, about the privacy of medical information. HIPAA is an interesting one because I interviewed a guy yesterday who is building, his firm is building the technology infrastructure for a $1.5 billion NIH project called All of Us. And what it aims to do in the next 10 years is to create a database of 1 million people in the United States, capturing the diversity of people in terms of their race, their religion, their age, their location, and so forth, tons of medical information, sociographic information, and so forth. And we really talked about security and privacy. And they spent 5 years developing a manual. It's 175 pages long about how this will work in terms of securing people's individual privacy while making the data available freely to researchers. And the really cool part about it is they're very specific that they don't mean researchers from Harvard or Stanford. They can have it too. They're opening up to all kinds of alternative researchers, citizen scientists, and so forth. It's really, I really want to watch this. 10 years is a long time, but I'm really kind of excited about this, and nothing like this has ever really happened before. But anyway, back to regulations. The UK has started their DPA, California has their CPA, there's the EPR coming out of EU, which is going to be even more critical than GDPR. And the point is personal information. It's a much more complicated topic than you might think. Because if you look at the left side of that table, name, social security number, driver's license, birth date, that's easy. That's personal information. The real problem is emergent, personally identifiable information. In other words, office location, business telephone. When you start pulling data from different data sources, it's not really that hard to back into a personal identification, even if you've masked the stuff on the left side. So it's really, really important that you can go through this data and find those things and deal with it, okay? Because I don't have to tell you this, that problems with sensitive data are very, very big problems. Okay, next topic.
But let's go into that just for a second. I mean, some 20 years ago, it was Scott McNeely, of course. We talked about this during last month's webinar, who said there is no privacy on the internet. Get over it. The pendulum, according to McNeely, was way over to one side. And now we see that pendulum coming way over to the other side. The question is, where does it stop? And is there an equilibrium? And that's something I don't know that we can answer here. What do you think?
Well, I know that my wife was a good Midwestern girl when I met her 45 years ago, but she claimed the other day that the only people who worry about privacy have something to hide. I don't buy that either.
No, I'm not. Yeah, exactly.
Here's the problem: when people have information about you, they can bug you and try to sell you things, and that's annoying, but it's not going to ruin your life. The real problem is identity theft, is discrimination in employment, in credit, in insurance, and those are real problems. I was actually talking to a life insurance company a couple of months ago, and she said, we do capture a lot of very sensitive information about people. And our policy here is that it's a privilege to have that information to do our underwriting, but once that's no longer an issue, it's our job to delete it. Isn't that interesting? I don't know that many companies feel that way.
No, as a matter of fact, one of the things that we've been talking about with others is that for a long time, companies were accumulating and amassing as much data as they possibly could, specifically because they were concerned that at some point they would be told they couldn't amass any more information. So they were getting while they were getting was good, if you will.
Yeah. Yeah. Well, that's kind of the big data paranoia. We've gone from managing from scarcity, which is how little data can we capture and how small can we make our applications because everything is expensive, to how much data can we gather because everything is cheap, except I guess a lot of CIOs have found out it's like that old Steely Dan line, it's cheap, but it's not free. I think that, oh God, things are just happening.
You're aging yourself, Neil. You're aging yourself.
I know, but things are just happening so fast. Relational databases came on, in a big way in the late 80s, and it took 20, 30 years for people to say maybe there's something else we can do. But the cadence of technology implementation now is like 2 years. And I have clients call me on advisory calls, and where I used to say, should I use DB2 or should I use Teradata for a data warehouse, or and now they say, my God, Kubernetes, containers, serverless, Hadoop, Spark. What are we supposed to do? And they don't know. I mean, it's very confusing because there's so much technology happening so fast. My advice to people is, just stop and take a breath, and think about the end game. What is it that you're trying to accomplish, and just work backwards from there. And I think that impact analysis is a good place to start, because you have to capture the changes in source data at points in time, and that's where you need a machine to do that for you, because you don't have time to sift through a petabyte of data across 400 servers and say, write some code and say, tell me if anything's changed. That doesn't work. So you do need this. Okay, what's the next topic we have here, Steve?
We are moving on to redundant data analysis.
Yeah.
There we are.
See, this is a big problem. If you were building a data warehouse and you were extracting data from Siebel or SAP, you didn't worry about this too much because the application took care of this. That was part of its job. And where it did have multiple copies of data, it had it for a reason, and you understood that. But when you're dealing across different data sources, and data sources that have been created by different organizations or entities, or even within your own organization, you can have multiple copies of data that conflict, and you have to find out what those are. A good example is if you have a data scientist, and the data scientist is running some experiments on data. They'll create a training set, they'll run it, they'll look at results, they'll make some changes, they'll save the training set and the data and the outcome, and they'll do that a few times. And then out there somewhere, you have multiple copies of this experiment, but they're different data. How do you know which ones are the right ones? Well, you don't, and you don't have time to find that. That's why you have got to have something that can sort through that using, like I said before, the relationship map. So the first thing you know is how everything is related to each other. And then from there, you can devise where's the redundant data and what to do about it.
With that in mind, time becomes perhaps the key element here. You don't have the luxury of saying, okay, we'll get to it next week, we'll get to it next month. Mm-hmm. It seems to me, and I may be off base here, Neil, but it seems to me that the regulators want to know that information about any given person who doesn't want their information retained is gone when those people want it gone. Mm-hmm. And you have to search and find it across multiple locations.
Well, you know, regulatory issues in terms of data are really only one aspect. There's another aspect of it, which is this person I spoke to in the life insurance company is we should be good stewards of this data. Just because we have it, we shouldn't take advantage of it. The other thing is you, as an organization, may be making promises or assurances to people that you'll be a good steward of their data. So it goes beyond, you know, statutory requirements or regulatory requirements, right? Anyway, redundant data is a huge problem because organizations have applications that are, you know, they used to call it shadow IT, applications that were built by line of business groups. They weren't as careful about things like referential integrity and redundant data and so forth. And if you start scooping that data up, you're going to be in real trouble if you don't pay attention to redundancies in the data. So here's the big kahuna, the automated data catalog, right? I can't stress this enough. All of the disciplines and fun and agony of dealing with data have to come down to a point that has some usefulness. And the usefulness is, where do I go to find out what data I need to do this analysis? Who else has used this data? How reliable is this data? What does it really mean? How is it related to other data sources? I have an interesting story to tell you about these data relationships. And this, by the way, has the added advantage of being the truth. A number of years ago, there was an auction of signed first editions and other collectibles. And a book came up, and it was a signed, inscribed first edition of Mark Twain's A Connecticut Yankee in King Arthur's Court. This was written in the 1880s, 1890s, sometime. Now, the person who was assigned to putting reserves on all of these different items knew who Mark Twain was and knew that a first edition of that age and that quality obviously had. And he went to collectibles, you know, comparables and so forth. But the thing is, it was inscribed as to my dear friend Nicola. Now, in terms of assigning a value to this book, if he had ignored that name, Nicola, he would have given it a price of probably $2,000 or $3,000. But it turned out that Nicola, and he didn't understand this until he used software that used graph analysis to create relationships, was about Nikola Tesla, who happened to be a close friend of Mark Twain's. So now you have signed first edition by Mark Twain to Tesla. Suddenly the value of that book skyrocketed. And the person assigning the reserve to that book would have never known that unless Nikola came up in his catalog as Nikola Tesla. You see where I'm going with this? He didn't ask for who the person was that it was inscribed to, but the graph told him. And that is the real value of it. That's the real value of a data catalog.
But that goes back to the 80/20 that we talked about earlier, that the data can present opportunities to you. Now, it could have been Nicola Raden or somebody else, but using the catalog, we knew, and by the way, that was your third cousin, correct?
Oh,
Nicola
no.
Raden, never mind. But understanding that it was Nikola Tesla, it's the human factor that comes into play that says, okay, all of a sudden, this is worth more than the 2,000 to 3,000 that you talked about, and takes it up to the 8,000 to 10,000. So it's a combination of the technology and the human analysis.
Well, what happened was, they have a relationship database of famous people and who their friends are and who they're married to and so forth. And when he punched in this book and the name Nikola, it immediately popped up and told him that's Tesla. And I don't even know if he knew who Tesla was. If he was 25 years old, he probably didn't. So then it started to tell him information about Tesla and their relationship. So, I mean, this is just kind of a silly example. I have a bunch of them. There was another one about a race car that was driven to victory by Paul Newman when he was 70 years old. And the auction had no idea until it came up in the catalog. So these things are very important. But it's not, the catalog is not based on a specific schema or model. That's what makes it so useful. And common repositories of metadata or master data management, where do companies go? They try to build it for customer, they try to build it for product, and then they're so exhausted they stop. It's just not enough. And you need an assistant. You need a machine learning / AI capability. And I can't stress this enough. And what I really, really liked about Io-Tahoe when I saw it was that it wasn't a bunch of different components that were cobbled together. The whole thing was completely unified. It started with the data discovery and the relationship mapping that flowed through all of the other modules that required, I'm not going to say no code because I haven't used the product, but so far as I can tell, very little to no code to get this work done. And the end result basically gives people a means to find the data that they need. And that's it.
Yeah, now you're also talking about, and if you take a look in the middle, we're talking about semantically rich data and a semantically rich approach. So we said we were going to ask about that off the top, and here's the question: what does semantically rich mean?
So I picked up this question from Wikipedia, and it turned out that actually Wikipedia got this definition from the Wayback Machine. I don't know how many of you know what the Wayback Machine is. You can basically specify a date, and it has a copy of the internet as of that date. And they went back something like 25 years to some government agency that was trying to describe what a semantic data model is. And that's where they got this concept. A conceptual data model, right? Okay, that includes the capability to express information, that enables parties to the information exchange to interpret meaning, semantics, from the instances without the need to know the meta model. Now, I looked at that definition and I said, that doesn't really tell me very much. So I came up with my own. I said semantically rich data communicates the context needed to understand the data's relevance and to make your life easier. And that's it. That's the whole point. I think this topic has been bandied around a lot. I know that 10 years ago, a number of startup companies were dealing with creating ontologies using RDF and OWL and Sparkle and that sort of thing. And the same thing, they were crushed under the weight of getting the work done because every piece of information in the world had to be tagged and put into an ontology structure and classified. That didn't work. Machine learning using data discovery and relationship discovery, it may not get you 100% of the way there, but it's going to get you close. And as you refine it, as you correct it, and you say, no, this isn't Doctor Who, it's Doctor, it gets better and better. And that's where you really want to be. I think it's a long-term solution.
So in conclusion, In conclusion, there we go.
Yeah. Well, machine learning is not going to solve the 80-20% solution, but it's your best hope right now. And it's going to make it possible to get useful progress done using it. And like I said, the way Io-Tahoe does it, which is starting with the data discovery, flowing all the way through this data catalog in a single organized platform, is going to reduce time and lead you to, well, I don't know, digital transformation, whatever that is. You've got to get the right platform for, I call this the culture of possibility. In other words, the culture of possibility says, God, this is a hard problem. I don't really know how I'm going to get my arms around it, but doggone it, I'm going to solve it. The inverse of that is, it's too hard, can't do it, forget it. And if you get the right platform, where people can begin to adopt that culture of possibility, because they'll see how much easier and fluid things are. And they're still going to have, you know, it's not a magic bullet, right? They're still going to have problems. They're still going to have to deal with messy data and making wrong assumptions and coming up with good models. That's not going to go away. But the 80 part of that 80-20 can be reduced significantly. And our research is that, you know, of all the different wrangling products out there, I haven't seen one yet that's as coherent and capable as Io-Tahoe in a single package. And, you know, that's my, what do they say? That's my whatever, and I'm going to stick to it. I can't forget.
That's your story. You're going to stick to it. I was listening to you talking about that it can't solve the problem and the culture of what is possible. It reminded me of the old quote that the perfect is the enemy of the good. You want to get as good as you can, but you may not be able to have it perfect.
Well, you know what, Steve? They call it work. I mean, if it were fun, you would have to pay to do it instead of getting paid to do it, right? There's still going to be work. There's still going to be frustration. I had a situation a number of years ago where we were building a dynamic pricing application for a CPG company. And we used a lot of very fancy math. But when we presented it to the CMO, we had 2 hours. We did the whiteboard. We didn't use any geeky words. We didn't show any continuous functions or differentiated moment generating functions and that kind of stuff. And we came up with what we thought was a really, really good approach. And at the end of the meeting, she looked at us and she said, good work, you guys. Let's keep talking. In other words, we hadn't convinced her one bit. Because even as we come up with these great conclusions, we still have to find a way to communicate them to other decision makers. And that is also a real problem. It's going to take some time.
It's the insight. And I think what I'm hearing you say is that the data catalog is an incredible tool, but it's only a tool that helps you get to the end game, to get to the finish line, if you will. And it is not the solution in and of itself. And
I would say, Steve, I would say it's more than a tool. Done right, I think it's an enabler. And it motivates and people and enhances their abilities to get to those points.
It makes things possible to a larger degree than anything we've seen up to this point. Now it's incumbent on us and others to continue making it better, to try and move along that continuum. Yeah. Because obviously the needs of people are going to change. They're going to evolve as well.
Yeah. Yep. Well, it's interesting times, right?
Absolutely, and we certainly live in them. Hey, folks, that basically is going to conclude our presentation here. Obviously, if you have any questions, you can reach us on Twitter at Io-Tahoe using hashtags AI and data catalogs. We do want to thank you very much for being with us. And we're going to stop recording at this point. But Neil Raden, I definitely do want to thank you for taking part in this. Neil is available. What's your website, Neil?
I shut it down.
Okay, never mind. Then hit nraden at hiredbrains.com.
Just Google Neil Raden, and you'll find a bunch of publish material on this stuff lately. That's the best thing to do.
Neil was very good, as you can definitely tell from this. He's certainly opinionated. Our website is www.io-tahoe.com, and we look forward to hearing from you. And again, Neil, thank you. And everybody else, we thank you as well.